Okay. The section 2 is all about rational expressions. Basically, if you see an expression, try to factorise it. So the first one is simplifying algebraic fractions. So factorise first and then cancel. Just as an example from the CA notes here. So just factorise it, no common numbers, common letters, and then cancel. So the 2 and the 10 cancel, the x's cancel, and the y's. Remember, you can't touch within the bracket, so leave it sitting. Next one is multiplying and dividing algebraic fractions. So just using the CA notes and working through them. Nothing factorises more than one term, so put brackets around it. Factorises by 2, put brackets around it, put brackets around that. The a plus 1's cancel off, giving you 6a over a plus 2. The second example, or the third example, sorry, is a division. But first of all, factorise. Nothing factorises, so you can put brackets around that, down there. Nothing happens there. That's a difference of 2 squares, and nothing happens there. To divide, you turn the fraction upside down and multiply. Those brackets match entirely, and only if they match entirely do you cancel them off, so they can cancel off. You've got an x and an x squared. Take an x out of that, it goes away. Take an x out of x squared, you're left with an x. So the top line is 2 over, and the bottom line is x minus 1. The next thing I'm going to do here is adding and subtracting rational algebraic fractions. So the first one, and before I do that, I remind you how to add and subtract fractions. You must have the denominators the same. So if you had 2/3 plus 4/5, you'd make them both out of 15. You'd times that one by 5 and times that one by 3. Once the bottoms are the same, you add the tops. Example 4 is exactly the same. They all go into 12. So put it over 12. Times this one by 4, this one by 3, and this one by 2. Once the bottoms are all the same, just add the tops. So 8 add 3 minus 10x. The second example that we have here is 1 over 2x minus 1 over x squared. Make the bottoms the same. So you're like combining the bottom lines there. So it's 2x squared. I need an extra x here, so put an extra x on top. I need an extra 2 here, so put an extra 2 on top. Bottoms are the same, just subtract the tops. The next question is algebraic division. So I'll go through this with you, hopefully it will be okay. So you're going to divide by this. So method 1 is your long division. So x into, this is your lead number, or your lead term. So x into 2x cubed goes 2x squared times. Now you take your 2x squared and you multiply it by these two. So 2x squared times x is 2x cubed, and 2x squared times minus 2 is minus 4x squared. Then you draw a line and subtract. The first two terms should always disappear. It's 2x cubed minus 2x cubed does disappear. Minus 3x squared plus 4x squared becomes plus x squared. X minus nothing is just x, minus 3 minus nothing is minus 3. Subtract, x into your lead number x squared, you need an extra x, so that's what that comes on top. Times this by x, so it's x squared minus 2x. Once you've done this, draw your line, subtract. X squared minus x squared is gone. X plus 2x is 3x, and minus 3 minus nothing is still minus 3. So x into your 3x goes 3 times. That's where that 3 comes from. Now do 3 times this. 3x minus 6. Draw your line, subtract. The first two numbers disappears as you should do. So it's minus 3 plus 6, which is 3. Now the way you can write this is you have taken that and divided it by x over 2. So that divided by x over 2 equals. That was your answer. It's called the quotient. Plus the remainder over your divisor, which is the way I've written it. Another way of doing this is equating the coefficients. So I'll run through this with you just to check it. So basically, what you do is you start with your expression. 2x cubed minus 3x squared add x minus 3 all over x minus 2. When you divide that through, x cubed over x is an x squared. So the highest coefficient of x you're going to have is an x squared. So it's going to be something x squared plus something x plus c, plus a remainder over the divisor. So what I would do here, so you've it set up, so that's what you're given, that's what your answer is going to be, plus your remainder over the divisor. You can see there's an x minus 2 there on each side. If you multiply this by x minus 2, it disappears. but you must multiply this expression by x minus 2, and multiply this by x minus 2, it disappears. Now what I'm going to do is I'm going to times out this middle bit here. So just timesing through that double bracket. Now I'm going to look at the coefficients of x cubed. I've got a 2 here and an a here, so a is 2. Now look at the coefficients of x squared. You've got minus 3 on this side, and on this side you've got minus 2a plus b. So minus 2a plus b. But you know what a is from above, so you now can work out your b. Then work out your coefficient of x. The number in front of x is a 1. Over here, it's a minus 2b plus c. You know your b, so sub it in, work out your c. Now do the constant, that's the number on its own. On this side, it's a minus 3. On this side, it's minus 2c, add d. Put your c in and work out your d. Then go back up to your initial setup. You've now got your a, b, c, and d. So just plugging it in and you get the same answer as before. A bit more cumbersome, I think, that way, but that really is your own choice. Example 6, number 1. You have to divide this by this. So I'm doing a long division. So take the top line, divide it by the bottom. X into the lead number goes twice. So 2 times your divisor, 2x minus 6. Draw your line, subtract. 2x minus 2x is gone, minus 5, add 6 is 1. So your answer is 2 plus the remainder over the divisor. Then it says sketch the graph. Now, that's what we're going to do over here. So the basic shape is a 1 over x graph. Then 1 over x minus 3. You're inside the brackets, so do the opposite to the x. So you're going to move it forward 3. So instead of it having an asymptote at the y-axis, it's going to asymptote at x equals 3. Then you've got to lift the graph up 2. So just lift it up 2. So instead of it asymptoting across the x-axis here, it's going to asymptote against the y equals 2 line. And that's your graph drawn.